flux balance. And if you remember, for any fluid mechanics problem, we try to do these three type of balances: mass balance, momentum balance, and energy balance. And this gives us a complete set of equations to find any parameter of our interest. Okay, so this is again the same setup that we have been considering, where we have a gravity current flowing in the ambient, but we have changed the frame of reference. We are now considering the gravity current to be static and the ambient to be moving. Okay, and these are some equations which we have already derived, which we are going to use in derivation. So for energy flux balance, we are going to simply use the Bernoulli equation, and we are going to find balance the Bernoulli constant between AB and CD. AB and CD, because we know we are considering inviscid flow, and in such situation, an inviscid flow and steady flow, etc., we can use Bernoulli equation, and the terms that comes within Bernoulli equation, that gives us total energy, right? So if you go from A to B, we can simply write P plus rho square by 2 plus rho gz dz is equal to C to D P plus rho u square by 2 plus rho g z dz. Okay, so if you remember, whatever you see here inside, this comes in form of Bernoulli equation. So this is called Bernoulli constant, right, which tells you the total energy a fluid has in terms of flow energy, pressure energy, kinetic energy, etc. Right? Whatever energy we have at point AB should be same at point CD, because we are assuming there is no frictional loss, so energy must be equal in both the sections. All right, so similar to momentum flux balance, let's now expand all these terms that we have. So in the left hand side, we go from 0 to H, and pressure at any point in the left hand side between A to B, we can define as PA minus rho A G Z plus this becomes U square by 2 plus rho A G Z dz. In the right hand side, we first go from 0 to H naught, and there we have PC minus rho naught G Z plus rho naught U naught square by 2 plus rho naught G Z dz, plus we now go from H naught to capital H, and there pressure becomes PE minus rho ambient G Z minus H naught plus rho A UA square over 2 plus rho A G Z. Okay, so these are all different terms we have, and let me quickly verify if I am writing everything correctly. All right, so in this equation, once again, if you recall that PC is 0, that is the reference point we are considering, reference pressure, which is equal to 0, and also U naught is equal to 0, right, and PA is known, and that is equal to minus u square, so that is minus rho a u square by 2, and also Pe is known, that is equal to minus rho naught gh naught. Okay, so these are four different parameters that we have which are known, and that's why we can simply use them in this equation. And other thing that you will see here is this term is same as this term, so they cancel with each other. Likewise, PC is 0, that is already defined, u naught is 0, so that becomes 0, and here again you will see that this term is same as this term, so they cancel with each other, right? So now expand this further, so this becomes 0 to h, where PA is minus rho a u square by 2 plus rho a u square by 2 dz. This side we are only left with this term, where PE is minus rho naught g h naught minus rho a g z plus rho a g h naught plus rho a u a square by 2 plus rho a g z dz. Okay, and once again you can see that these two terms are same, so they cancel with each other, and these two terms are same, so that cancels with each other. Okay, so these are all the terms that we have which cancel with each other, and finally we get the equation of the form where left hand side is simply 0 and right hand side becomes h naught to h minus rho naught g h naught plus rho a g h naught plus rho a u a square by 2 dz. Okay, so this is the simplified equation we get after cancelling all common terms. So what do we get here? Now we know that this is an integral of whatever parameters we have here, and it says that integral is equal to 0, right? That actually means that whatever we have inside here, that must be equal to 0 to satisfy the integral, right? And that is why this term we write as g h naught plus rho a g h naught plus rho a u a square by 2 must be equal to 0 to satisfy the integral, which itself is equal to 0, and that is why we don't have to integrate it, we simply can consider that to be 0. All right, and what do we get here? So this, let's write here as 2 plus g h naught, or we can rho naught minus rho a is equal to 0, and we can pull one term to the other side, so this becomes g h naught rho naught minus rho a, and we'll divide it by rho a, so that becomes, and we'll, okay, so this actually becomes by 2. Okay, this simplified equation, and once again we know that rho a minus rho a divided by rho a times g is equal to g prime, that is the radius gravity. That is one thing we know, and the other thing is ua is equal to capital UH over H minus H naught, capital UH over H minus H naught, that is small ua. So now if you replace these terms, we will get G prime H naught is equal to U square H square over H minus H naught square divided by 2. Okay, and we can pull the U square term from the other side to the left, and this becomes G prime H naught over U square, and that gives us H square over 2 H minus H naught square. Okay, and this term we are trying to derive similar to this what we have derived for momentum flux, and there we have U square at the top. So what I will do is we will just replace the denominator with numerator. So this becomes H naught is equal to 2 H minus H naught square over H square. Okay, in this equation that we have derived here is the energy flux balance. Okay, let's call it equation D. Alright, so far we have derived mass flux balance, which let's quickly look into it. Equation B here that gives mass flux balance that relates velocity, the disturbed velocity with the undisturbed velocity. And then we did mass flux, momentum flux balance by balancing forces, and that gives us this equation, that is equation number C, and we have U square over H naught G prime as a function of capital H and H naught. And then we further derived energy flux balance, and that gives us this particular equation, equation number D, where again it is same as momentum flux balance, the left hand side, that is U square over G prime H naught, and the right hand side is in the form of capital H and H naught. Okay, so these three equations we have derived, and now we are going to use these equations to solve for the gravity current to find the parameters of our interest.